Good morning, friends. Do you have any curiosity to know why the satellite signal sends at A and signal sends at B? How does it know about it? What are the major things what a satellite required to know the position of A and B? How does it know the exact location of A and B? Hello student, my name is Ashish Maurya. I have done my BTech from Government Education College Raipur. I am doing my masters from NIT Raipur. Today we are going to learn about vectors. Why vectors is very important and where this vector is going to be used. Does it has magnitude? Does it has directions? All these questions comes in our mind. 3. Before knowing about vectors, we have to know about physical quantities. What are physical quantities and why it is very important? Physical quantities are those quantities which we can measure, which we can feel, we can observe. These quantities are very important to understand before knowing about vectors. So physical quantities are of two types. First one is scalar quantity. Second is vectors quantity. What is a scalar quantity? Scalar quantities are those quantities which has magnitude. Okay? Scalar quantities are those quantities which has magnitude. For example, mass, temperature, pressure. Mass is a physical quantity, is a scalar quantity which can be added or which can be subtracted. For example, my mass is 50 kg and your mass is 40 kg. So total we can add this two mass, 50 plus 40, that is 90 kg. Similarly, temperature. Today's the temperature is 27 degrees Celsius. Might be tomorrow it is 30 degrees Celsius, or might it be cold. So temperature can also change. Now talking about vectors. What is a vector? Vectors are those quantities which has magnitude as well as directions. Okay? Which has both magnitude as well as directions. So such quantities are generally represented by a cap or vectors. So how to deal with such quantities? Vector quantities, for example, velocity, displacement, momentum, torque, all such quantities are vector quantities which has directions, which you can measure, whose direction you can be known. So all these things we are going to learn in today's class. So now we are going to learn about representation of vectors. Vectors are represented by three caps, that is I, J and K. What are its magnitude and why these are only used? I represent the direction in X and it has magnitude of 1. What is its magnitude? 1. Similarly, J represents the direction of Y and it has also magnitude of 1. Similarly, K represents the magnitude direction of Z and it has magnitude of 1. Why it is very important? This is cap. This is generally given to those vectors whose magnitude is 1. Okay. So right now we are going to talk about vectors. Vectors is generally denoted by R and it has direction that is represented by a arrow. What is R cap? R cap is a unit vector. And how to represent this R? R cap is a unit vector which is represented by R vector along with divided by its magnitude. So this is the R vector. So students, now we are going to know about how vectors can be added. There are two laws, that is parallelogram law and triangle law. These two laws are required for addition of vectors. So right now I am going to explain you about parallelogram law. So this is the origin O. From this a vector is there, that is OA. And from this another vector is there, that is OB. And this vector A is A vector and this is B vector. How this can be added and what will be its resultant? So this vector can be added and the resultant is represented by the diagonal. Since this vector generally forms the shape of a triangle, of a parallelogram, so this is known as parallelogram law. So this vector is actually a coplanar vector and it actually generates from a same plane and same point, that is origin O. Okay, so this is the parallelogram law. How this vector can be added? Suppose this resultant vector is R vector. and it is represented by A vector plus B vector. And this is parallelogram law of vector. Now we are going to talk about triangle law. Triangle law is basically like a head to tail connection. The head of first coincides with tail of second. This is A vector, this is B vector, and the resultant will be another vector, that is C vector. And this C vector is generally represented by A vector plus B vector, and this C is resultant vector. I have already said this. This is a coplanar vector. I mean, this is lying in the same plane, and this they originated from the same point, that is O. And here there is a head to tail connection. Head to tail connection where a vector A and vector B had a head to tail connection, and it is represented by vector C, and it forms a triangle, and here a parallelogram is formed. So this is the basic difference between the parallelogram law and triangle law. Suppose there is a vector AB. We need to find the position of AB vector and how to denote this position vector of AB. So basically we have to draw this vector in a Cartesian coordinate, and how to find the vector AB, the position vector. This is the main question that comes in our mind. First of all, we have to make two other vectors in order to determine this third vector, position vector, that is AB. So from O to A, we have to create a vector, that is A vector. And from O to B, we have to create another vector, that is B vector. So this is forming a triangle. So which law we should use? Triangle law. Triangle law should be used to determine this AB vector. So the position of AB vector can be determined by triangle law. Position of AB vector. How to determine it? This is a question mark. Since we know that head of vector A coincides with tail of vector AB. So vector A plus vector AB is equal to the resultant vector B. So AB vector is equal to the B vector minus A vector. From this way we can find the position vector of AB. This is the simplest thing. Let's go for example. Suppose if this has a coordinate of 2, 2, 3 and this has coordinate of 4, 5 and 7. Okay. A has a point which has a position vector of 2, 2, 3 and B has a point which has a position vector of 4, 5, 7. How to determine this AB position? First of all, we have to draw a line from the origin and determining the vector A vector, and secondly we have to determine the B vector. Same thing we have to use a triangle law. At the end, AB vector can be represented by B vector minus A vector, where B vector can be determined with the help of the previous thing, ij cap. We already know about ij cap. Ijk caps can be used to determine the position of A as well as the position of B. So the position of B is 4i plus 5j. Here you can see this coordinate plus 7k. Let me rub this board. Now we have to determine the position of B. The position of A can be determined by 2i cap plus 2j cap plus 3 cap k cap. And now the position of AB will be vector AB is equal to vector B minus vector A. That is equal to AB vector will be equal to that is B 4i plus 5j plus 7k minus 2i plus 2j plus 3k. So resultant will be 4 minus 2. We have to subtract I first, then JJ, then KK. 4 minus 2, it will be 2. 2i. 5 minus 2, it will be 3. 3J plus 7 minus 3, it will be 4K. So this is the position vector of AB. So we can write this is the position vector of AB. So I have asked you a question in the beginning. How this satellite comes to know the position of A and B? This is generally because of the vector, position vector. We can find the position vector of A and B A has a Cartesian coordinate x1, y1, z1, and B has a Cartesian coordinate of x2, y2, and z2. With the help of these coordinates, we can determine the position vector of AB. By determining the position vector of AB, since we know that vector is those quantity which has direction as well as magnitude, so we can find the magnitude as well as direction of AB. So how the direction and magnitude of these two positions can be determined? So generally we know the magnitude can be represented by the Cartesian coordinate x2 minus x1 का whole square plus y2 minus y1 का whole square plus z2 minus z1 का whole square. This is over under root. This is used to determine the magnitude of position vector AB. And how this direction can be determined? Direction can be determined by, since we know the formula tan theta, that is y2 minus y1 divided by x2 minus x1. So by this formula we can determine the tan theta, or we can find it out by using some different laws. Like if the position vector is A vector, this is B vector, so we have to determine the distance between A and B. So determining the angle, we can generally denoted by cos theta is equal to B vector multiplied by A vector upon magnitude of B vector multiplied by magnitude of A vector. So this formula can be used to denote the directions between the two vectors A and B. So now we are going to learn about plane and line. Line, generally we know that it is determined by position vector AB. Now we have to determine the position vector, we have to determine about the plane. How we can determine a plane, how position vectors, a line determining the position vector AB can be defined in a plane, that is XYZ. So basically this plane can be determined by direction as well as magnitude. Suppose this is the direction, this is the angle, and this angle is theta from y-axis. This is the angle alpha from x-axis, and this is the angle beta from z-axis. So how to determine this plane? This is the main question that comes in our mind. So there's three angles can be used to determine the directions, and generally cosines are used to determine this angle. The cos theta is represented by, cos alpha is represented by L, cos theta is represented by M, and cos beta is represented by N. And now if there is any line which has coordinate like A, B, C, which is passing through this plane, so how to determine the position of this plane, the position of this line in the plane, all these things comes in our mind. So general formula that we are going to use is x minus A divided by this cos alpha, that is L, is equal to y minus B divided by M is equal to z minus C divided by N. This is the basics formula that we generally use to determine the equation of a plane. Now comes to question, how to determine what kind of questions can come from this. So students, first of all, note this question. This is one of the question asked in JEE Advanced 2023. Write down the equation of the plane, passing through point 1, 1, 1. This is the Cartesian coordinate, and perpendicular to the plane 2x plus y minus 2z is equal to 5, and 3x minus 6y minus 2z is equal to 7. That means there are three planes, and these three planes are perpendicular to each other. So now we have to find the equation of a plane which passes through 1, 1, 1, 1, 1, 1, and it is perpendicular to this plane as well as this plane. So students, since we have this point which is passing through 1, 1, 1, so what is the plane? First of all, we have to find the plane. We know the general equation for the plane is ax plus by plus cz is equal to lambda. What is lambda? Lambda is an intercept, or we can say as a constant. And generally we have to put the values of x, y and z. X is 1, y is 1, and z is 1. So this is the equation of plane passing through point 1, 1, 1. This is the first equation. And the second equation is ax plus, this is the second equation. Okay, on subtracting both the equations, we get this. Subtracting first with second or second with first. We can find it by subtracting first from the second. So subtracting first from the second, what we get? From the second, ax minus 1 plus by minus 1 plus c z minus 1. So this is the equation we get after subtracting 1 with 2. Okay. Since we have two planes, P1 and P2, and third plane that we have already divided as ax minus 1 plus by minus 1 plus cz minus 1 is equal to 0. This is the third equation. We generally know that the cos theta is equal to a vector multiplied by b vector divided by magnitude of a, magnitude of b. Since the theta is 90, these two planes are perpendicular to the third plane. So the theta will be 90 degree. And we have to equate the a vector multiplied by b vector, dot product, and it is equal to 0. The a vector will be this third equation, and the b vector will be either the plane containing P1 and P2. So a vector will be 0a multiplied by a I plus b j plus c k. And this is the equation 2I plus j minus 2k. This is the line. By solving this, we get 2a plus b plus minus 2c. This is the fourth equation. Okay, and we have to do similarly for obtaining the fifth equation. This is the fourth equation we have obtained. So we have now two equations, third equations and fourth equation. Now we have to obtain the fifth equation. This is basically for line. In order to determine the line, we have the plane 2x plus y minus 2z. So the line will be 2I plus j minus 2k. This is the plane containing this line, and this plane containing this line, and both the dot products we are going to get 2a plus b minus 2c. So friends, now we have derived equation number 3, equation number 4. Again, by using cos theta, theta is 90 degree, we can derive the equation number 5th. So equation number 5th, generally we have to take this equation, equation number 3, and the plane second. So plane second. So generally we will write it as ai plus bj plus ck. This is the line which is contained in this plane multiplied by this second plane 3i. This is the line contained in this plane plus minus 6j minus 2k. On solving this equations, this is equal to 0. On solving this both the equations, we are going to get a plus minus 3a minus 6b minus 2c. This is our fifth equation. So we have derived 5 equations. So students, we have obtained 3 equations, equation number 3, equation number 4 and equation number 5. And we can solve it by using cross multiplications. We all are aware of determinants. We are going to take the determinants, and solving these 3 equations, we are going to find the equation of this plane, of this line which contain the plane 1, 1 and 1. So basically we have to calculate the matrix. We have to form the matrix y minus 1, z minus 1, 2, 1, minus 2, 3, minus 6 and minus 2. Now we are going to find out the plane which containing this, the equation of the plane which contain this line. So we are going to, since we know that this x minus 1, we have to write it down as it is. Then we have to multiply 1 with minus of 2, minus 6 multiplied by minus 2, minus 12. Minus 12 of minus, this will be 12, plus second equation, we have to obtain minus 1 to the power of y minus 1. Then we have to multiply 2 with minus of 2, minus of 3 with minus of 2, plus third equation. Third will be z minus 1. We have to obtain 2 with minus of 6, then minus of 3. After solving this equation, we can find out the equation of a plane which contains the line 1, 1, 1. So we have to calculate it step by step. Minus 2 with minus 12, it will be minus 14. Okay, this will be plus 1 minus y. 2 with minus of 2, it will be minus 4. Minus of 3 with minus of 2, minus 6 it will be. Plus z minus 1. 2 multiplied with minus 6, minus 12, minus 3. After solving this equation, we will get something like this. X minus 1 into minus 14 plus 1 minus y minus 4 plus 6, it will be 2, plus z minus 1 minus 12 minus 3 minus 15. Now we have to solve this equation. Minus 14, it will be minus 14x plus 14 plus 2 minus 2y minus 15z plus 15 equal to 0. Now we will solve this equation. Minus 14x minus 2y, we have to, let's join the coefficients to one side and constants to another side. Minus 15z plus 14 plus 2 plus 15 is equal to 0. Now minus 14x minus 2y minus 15z plus 14 plus 15, it will be 29, plus 2, it will be 31. After, we have to multiply minus 1 here on LHS and minus 1 on RHS. So it will be 14x plus 2y plus 15z and it will be minus 31 is equal to 0. So this is the final equation of our line that we have to derive. Thank you.